Brandon is president of the PubPeer Foundation and the founder of the website PubPeer.com, which launched in 2012. And is also the PubPeer Foundation has launched a new project. The name is Periodicals.com. And Brandon is also a group leader with the CNRS in neuroscience. And you will see how the power of researcher is acting today for new initiatives and new, also innovative way of publishing. Thanks, Brandon, and 20 minutes.
Okay, yeah, I'll do my best. Thank you for the invitation. My name is Brandon, and this website, PubPeer, launched in 2012. I am, I guess, the principal creator of this website. And the overarching idea of the website is to kind of change the way that we assess science and to reduce the luck that is involved when several reviewers assign an impact factor to an article and put the assessment back into the hands of the scientists where we can collectively assess articles together. The inspiration for the website was from journal clubs. Myself, participating in journal clubs since I was an undergrad, I can say that I've probably never been to one journal club where we left the room saying the article is perfect, nothing to critique. There's always some issue with the article. I mean, often it's a minor issue, sometimes it's a major issue, but there's always an issue to critique in an article. And I was always disappointed that the authors couldn't participate in those journal club discussions. We had these criticisms and there was just no way for the authors to clarify something that we may have understood. And if we had understood correctly, there was no way to distribute that information from the journal club to other people interested in the articles. And so the website is a platform for doing that. You can look up any article, enter it into our database, and you can leave a comment on it, a journal club comment or any other type of comment. And we think that these comments, these issues that we find in articles when we read them by ourselves or when we read them in journal clubs are extremely important because these articles are the basis for the scientific record. And we are basing our current and future research on the scientific record, including clinical trials. And so if there's a problem with an article, that can affect our future research, the experiments that we're planning to do building off of the articles that we're reading. And this can have major costs. It can have financial costs because we could be wasting taxpayer dollars trying to build on research which is fundamentally flawed, but also has human costs because the people doing the research are usually students and postdocs at the beginning of their career, and if they're wasting time, many years trying to build on something that they just simply could not have built on, this can destroy their careers. So there are financial and human costs to scientists for problems in the scientific record. Also, of course, public policy is built on the scientific record, and innovations in healthcare are built on the scientific record. And so problems with the scientific record can cause them problems as well. An extreme example of this, of problematic science affecting, I can't figure out which one is the pointer here. Okay, affecting public policy comes from this example from Don Poldermans. So Don Poldermans was a cardiologist, and he basically published some findings saying that a liberal use of beta blockers after an operation increased the survival of patients. And it turns out that there were problems with the research, but those problems weren't discovered before the European Society of Cardiology produced a guideline recommending the use of beta blockers after operations. And some people have done the math of how many people were operated on under these guidelines over X amount of years, and how many of those people actually died. And you come up with these astronomical numbers of 800,000 people died throughout Europe. So it turns out that this research was fundamentally flawed. There was misconduct involved, and it made its way into a public policy guideline, which ended up having huge effects on the population. So that's admittedly an extreme example. Another example is the Wakefield case. So Andrew Wakefield published a paper in 1998 making a link between the MMR vaccine and autism. And that paper turned out to be, had falsified data in it. And after the paper was published, this is the case of the number of measles case, or this is the number of measles cases per year in England. You can see that there's a huge increase, and you can see that the percentage of people of the population getting the MMR vaccine was decreasing at the same time. Okay, and this is probably because, or a huge component of this was that this paper was greatly amplified and weaponized on social media for people that had this belief that vaccinations were causing measles, and because this paper was still there, could still be used by these communities to make the case that vaccines are causing measles. And it wasn't retracted, or eventually it was retracted in 2010. But in these 12 years that the paper existed, it caused major problems for measles vaccinations. So those are two examples of, two extreme examples of problematic articles. Is this really representative of all of the articles that are being published? This is something that's really hard to assess, just how many flawed articles there are out there. But I'll give a few examples. These are somewhat dated now, but I think they're still valid. This is a comment that was published in Nature a few years ago. Several years ago now, in which the pharmaceutical company in the United States in California, Amgen, said that they tried to reproduce the findings of 53 papers in cancer research that they considered to be landmark papers, landmark findings, because they wanted to reproduce these papers in order to build on them to make medications. And they had huge financial incentives to be able to reproduce this research so that they could produce these drugs. But despite those incentives, they could only reproduce 6 of the 53 papers, 11% of the cases. So most of the data that they just tried to reproduce from these landmark papers, they simply could not reproduce. Another example from a different pharmaceutical company, this time Bayer Healthcare in Germany. Again, cancer research, they tried to reproduce 67 projects and could only reproduce 33% of them. Again, a pharmaceutical company with extreme incentives to be able to reproduce the research, just completely failed to reproduce the research. It's not only cancer biology that has the problem. This is an example from psychology. This is a nice project by the Open Science Framework, which is a huge coalition of labs working together with authors. And they took 100 experimental and correlational studies from different psychology journals and worked together with the authors to try to reproduce the results in those articles. So again, working with the authors. And despite the fact that they were working with the authors and there were many labs coming together, they could only reproduce 39% of the effects in those papers. Okay, so it seems that, at least cancer research and psychology, and I guess, looking at PubPeer, that there are other fields that have these problems also. There are significant problems with the scientific record. And to back me up on that, Francis Collins, the head of the NIH, was recently quoted saying that the complex system for ensuring the reproducibility of biomedical research is failing and is in need of restructuring. So there's a huge problem, or it seems that there's a major problem with our scientific record. What's causing that? My personal view is that the pressure to publish is playing a major role in that. The incentives for us scientists are to get the next grant, to get the promotion, and to advance our careers. And the best way to do that is to publish in the highest impact factor journals, so the CNRS journals, Cell, Nature, Science. And unfortunately, these best journals are not necessarily interested in the most reproducible research. They're interested in the high impact research that's going to sell more journals, that's going to make a splash, that's going to make headlines. And getting our research into those journals and to make them splashy so that Science, Nature, and Cell are interested can come at the expense of careful work. And so I think that there is a lot of incentive for us to make sure that this gets into the highest impact factor journal possible, and that can't compromise the science. And I think that's probably one of the main reasons that we see these problems with the literature. So why are the problems still out there? Why is it difficult to correct these problems if they're being identified? I think the major reason for that is because there are huge conflicts of interest built into the system. So if you write to an author and say, look, I've noticed that there's this problem in your paper, and you do this privately via email, there's very little incentive for the author to say, look, you're right, we're going to fix that. I mean, it's better for him to, because this article is so important to his or her career. 5 minutes? Okay. So there's incentive for him to kind of ignore the problem. So then you write to the institution. Well, the institution may have brought in a bunch of grant money based on this publication. And so if there's a problem with the article has to be retracted. This has implications for the funding of the university. So they really don't have an incentive to do anything either. Write to the journal and say, look, we found this problem with one of your articles. Obviously, the journals don't want to admit that their excellent curation abilities have failed, and that there's a problem in one of their articles. So there are conflicts of interest built in through the system that make it very difficult to correct these issues when they come up. And therefore, the scientists that are consuming these articles are not made aware of these problems because it's just not corrected in the scientific literature. So the idea of the website is to kind of circumvent all of these intermediaries, and as soon as one of us scientists finds a problem with a paper or an issue with a paper, we put it online, and immediately anybody who's interested in that article can then be made aware of it. So other scientists, other public policy makers, and whoever else is interested in the article. And the website has become quite successful. So we launched it in 2012. It now has over 70,000 comments. And that's on 14,000 articles in 2,300 different journals. And this is the evolution of the number of comments that are received on PubPeer per month. And I show this for two reasons: to show that it's increasing. It's kind of leveled off now. But the other thing is to show that this, in comparison to the commenting system that was built onto PubMed Commons. So that has been stopped recently. The reason they give is because there were other platforms that were basically outperforming them. So I take that as PubPeer. But the major difference between their platform and our platform, one is that PubMed obviously is a very popular website. All of us scientists know about it, and most of us probably visit it a couple of times a week. So there's a huge influx of people that know about this website. The comments on the website get a high visibility. The other difference, and PubPeer didn't, at least when it started, did not have that sort of visibility, at least at this point, when we compare these two curves. And the other difference is that on PubMed Commons, you have to sign your name to your comments. If you write a comment, you have to say, it was me, Brandon Stell, that wrote this comment. And PubPeer allows anonymous comments. So this is what we think has made the platform so popular. This is when we allowed truly anonymous comments. At this point here, you can see what happened. The commenting just took off after we allowed completely anonymous comments. We think that there are several reasons for that that I'll get into later. But there's also risks of anonymous comments. And we have built into the platform several safeguards to kind of limit those risks. Comments, the golden rule of PubPeer is that comments have to be based on publicly verifiable information. So you can't come on PubPeer and leave an anonymous comment that says, look, I heard that in Jerome Lecoq's lab, they don't wash their glassware, and that's why they're, seeing what they see, okay? It has to be something that everybody can look at. Usually that's a figure in a paper. And so you write a comment, look at figure 2, the data are, you know, whatever. It has to be based on a publicly verifiable piece of information. Comments are moderated. So every single comment is viewed by a moderator. And we have a small pool of moderators, so the comments cannot be moderated based on their scientific content because the moderators are not experts in every field. But what they're moderating for is to make sure that people are sticking to this golden rule and that the comments are publicly verifiable. 2 minutes? 3 minutes? Okay. And so there are also facilities for reporting abuse. The authors have a permanent right of reply, so they can reply right next to the original comment with the same visibility of the original comment. And then, of course, there's community surveillance, just like on Wikipedia. The community participates in this moderation as well. And the other thing to keep in mind is that so this anonymity kind of rubs some people the wrong way, and commenting on their articles, especially anonymously, rubs some authors the wrong way. And I think one thing to keep in mind is that publishing the article was the author's choice. To put that out for the community to evaluate was the choice of the author. And I personally feel that there should be some responsibility for that, some, service après-vente for, keeping the, maintaining your claim in the article. And so the website has become quite successful. And if we compare this situation, so this is another article that was published, I think it was in 2016. Might have been 2017. And it was another article claiming that there's a link between vaccines and autism, okay? And the article was published on September 5th. The first comment appeared on PubPeer on September 20th, and it pointed out, fundamental problems with this article, with the data in this article. And the paper was then retracted October 10th. Okay, so because of this conversation, this public conversation of the paper, the article could not be used by anti-vaxxers to try to convince other people to not get vaccines. And so I take that as a major success of the PubPeer commenters that left these comments. The other thing we've done is we've created what are called browser add-ons. These are just little pieces of code that you can plug into your browser. Very easy to install, few lines. And what they do is they just look, when you're browsing the internet, they just look to see if one of the papers that you're browsing has comments on PubPeer. And if it does, like this vaccination paper, then it puts this box here to tell you that there are comments on PubPeer, so you can easily find comments on PubPeer. And they appear on basically all major websites where articles appear. The other thing that we've recently created is Periodicals.com. This is kind of a complementary site to PubPeer. PubPeer is a very critical website. There's most of the comments are critical comments. And Periodicals is a way for us scientists to create editorial boards or do it individually and pick out the articles that we like the best and create our own journal, our own overlay journal. So it's a platform to easily allow people to create their own overlay journals. And we've built in basically all of the features that normal journals have, except we don't host the actual article. The actual article is hosted on the archive, bioRxiv, or even on Nature. But you can, if you become an editor, send the article out to review and collect reviews, and then eventually publish the article in your periodical. The goals of the website is to continue growing this worldwide journal club in order to quickly... Okay, but this last slide. Just quickly pass information between scientists and put the focus on the data instead of on the impact factor of the article. And we think this will help encourage wider use of preprints. And the site fits into a larger ecosystem of post-publication peer review. One more important point, this website Retraction Watch is a major component of this post-publication peer review ecosystem because they're bringing these issues of research integrity to a wider audience and making the other sites all much more powerful. Okay.